it's Mrs. Valletta. I'm going to give you a little bit of help for your warm-up questions. I will not be going through everyone in this video. You can look at the answers that will be available online. All right, so we got a 2,000 kilogram car traveling at 15 meters a second when it gently applies the brakes and slows down to 5 meters a second. So we have a change in velocity, and that change in velocity occurred in 20 seconds. So remember, impulse is change in momentum. We have two equations for change in momentum. Its impulse is either the mass times the change in velocity, or impulse is the the force applied over the change in time. And so if you want to calculate the impulse, it looks to me like you'd probably have to use this equation. Remember, delta V means the final velocity minus the initial velocity. So you're going to have to substitute that in for delta V. If you're figuring out the force, well, we have the time at 20 seconds, so you could use this formula and you could rearrange it for force. Remember, if these two things are next to each other multiplying, the opposite of multiplying is dividing. So the equation that you're going to want to rearrange is delta P equals force times change in time. We have a change in time of 20 seconds up there. And finally, if we took less time, so I want you to think that about this, if you take less time to stop, if time goes down, remember, momentum is conserved and the car is definitely going to come to a stop, then what do we expect? We expect to see the force go up. And you can use the same formula that you derived in the first problem to do it. So those are my hints for page number 1. For page number 2, again, we have an impulse or a change in momentum. And you can refer to the equations on the first page. The force of impact, that's what we call when we're looking at delta P equals Ft. That force is called the force of impact or sometimes the impulse force. So you want to go ahead and try to figure out that impulse force. Remember, you have a mass, you have an initial velocity, and you have a final velocity. So you're allowed to combine both impulse equations. So if impulse is also equal to m delta v, then you could combine these equations and you could make one big equation that force times time equals mass times delta v. And again, you have to rearrange for force. So, we've talked about this before. If time is in the way and you're multiplying it, you should probably divide both sides by time. This comes from your readings and your movie watching about safety features, and I'm really asking you to think about, are we trying to change the force, the time, or a combination of both? And explain to me how you do that. All right, the blob problem. Okay, so these guys up here, these guys are really about change in momentum. They're not really about conservation of momentum. When we're talking about the blobs, and the blobs sticking together, that's an inelastic collision. And I want to remind you that these are two objects. This is the big blob and the little blob, and they combine together to make one blob. And so the momentum is conserved. The momentum initial has to equal the final momentum. So if you've calculated the momentum of this blob and this blob, you can add them together and you'll know the momentum of the system. This is like the cannon problem. We want to find the velocity of the big blob after the collision. And remember, after the collision, we're going to have the big blob plus the small blob. They're going to be one mass together. So that should help you do that one. On the third page, let me give you a little more advice on the third page. On the third page, we have two balls. This is an elastic collision. We've got two balls before the collision and two balls after the collision. The interesting thing about this one is that we can assume that we've got one ball that's not moving, and afterwards, and I don't know if you've seen this in pool, but the final velocity of the cue ball is going to equal 0, so momentum is conserved, and the mass of pool balls are the same for all pool balls. So I hope that helps you with this one. And the last one is this inelastic collision. We've got two objects. Remember, momentum of object 1 plus momentum of object 2 before the collision has to equal the two cars added together, mass 1 plus mass 2, times the final velocity after collision, because this is the momentum of P1 plus P2 after the collision. All right, I hope that helps you figure out how to do these problems. You can check your answers when you're done, and don't forget to upload a picture of your done work into Canvas. Goodbye.